Okay, sphere, the volume is 4/3, or I usually say 4/3, times pi times r cubed. R, of course, is being the radius of the sphere. You can see it there in the figure, what the radius of that sphere looks like. Cylinder, the volume is pi times r squared times h. So r is, of course, again, the radius of the circle. That's the base of the cylinder. And h there is the height of your cylinder. The cone is, and they have it written as over 3. I typically look at it this way. I do 1/3 pi r squared h. It's the same difference, okay? Multiplying by 1/3 and dividing the whole thing by 3 is the same difference. So if you would rather look at it that way, some people like to look at the formula with the 1/3. Some people like the divided by 3, okay? It really doesn't matter. It's the same difference. And again, r squared is still the radius squared. The radius is that circle, the radius of the circle. And the height there is the height from the tip of the cone to the center of the circle. It doesn't come up very often, but sometimes they may give you this length. They may give you the length of the side of the cone instead of the height of the cone. But what's happening there is you just have a right triangle. So if they give you this length, and a lot of times they'll use a cursive L, that's the slant height. If they give you that, then you simply use the Pythagorean theorem to find the height that you need to use in your volume formula, okay? So r squared plus h squared equals L squared. If they were to give you that. I have not seen that very frequently at all, but I did want to go ahead and mention that just in case they do give you that height instead of the perpendicular height. Okay? So those are the formulas. Let's look at a few examples here of using the formulas. Sometimes we will leave the volume in terms of pi. What that means, if it says leave it in terms of pi, then you just don't multiply the pi. You multiply everything but the pi. Or if it asks for a decimal value, then of course you do multiply out the pi. So let's look at this first example here. It says Francisco is making an effort to drink more water and has set a goal of 2 liters per day. He wants to know the volume of the water bottle he takes to school each day. The water bottle has the dimensions shown in the diagram. What is the volume of Francisco's water bottle? So this one's just a very, very simple plug and chug. Let's write down our volume formula just to give us another opportunity to learn it. Okay, volume of a cylinder is pi r squared h. So let's plug in the specifics. The radius here is 4. The height is 20. Let's start by leaving this in terms of pi. So all we're going to do is the 4 squared times 20. So 16 times 20 is 320. Pi. We always need to put units on a real-world application problem like this. So if our lengths are in centimeters, what is our volume going to be? Centimeters cubed. Okay, centimeters cubed. If you're ever wondering where does this come from, look at what we did. We took centimeters and we squared it. We had 4 centimeters here squared, so we got centimeters squared. And then we multiplied it by another unit that had centimeters. So we had centimeters squared times centimeters. That's going to give us centimeters cubed. Now, if we need a decimal approximation of this, then we're just going to turn around and multiply it by pi. So we get 1005.3, we'll say that's 31 centimeters cubed. That means a little bit more to us, right, than leaving it in terms of pi. But pi gives us the exact answer there. Now, let's see. How many times is he going to have to, this question isn't on there, but I want to add it. How many times will he need to refill his water bottle? Refill to meet his goal. So what do we need to know there? How many cubic centimeters are in 1 liter? Okay, how many cubic centimeters are in 1 liter? So there are 1,000 cubic centimeters in 1 liter. There are 1,000 cubic centimeters in 1 liter. So right now, we have our volume is 1,005 cubic centimeters. We need that in terms of liters, right? So a little conversion here. We need liters, so liters goes on top. We have cubic centimeters, so our cubic centimeters go on the bottom. So we take our number, divide it by 1,000. So, I mean, 1 water bottle is pretty close to 1 liter. So he'll have to refill it at least 2 times. Well, excuse me, refill. He would refill it once, but at least 2 water bottles full. He'll need to drink just a little bit extra to truly reach that 2 liters, but his water bottle is almost 1 liter. Okay, so this is what the question truly asked. What's the volume of the water bottle? But I added the extension because a lot of times I've seen these problems, they're not just asking you for the volume. They ask you something like this. So you got to figure out the volume, but then you have to extend it past that. Any questions? All right, let's look at this one. Jackson buys a grape snow cone on a hot day. By the time he eats all the snow off the top, the paper cone is filled with 27 pi cubic centimeters of melted purple liquid. The radius of the cone is 3 centimeters. What is the height of the cone? So they tell us that we're dealing with a cone. So let's write down our volume formula for a cone. Volume of a cone is 1/3 pi r squared h. Now, notice this is very, very similar to the volume formula of a cylinder. It just differs by that 1/3. That's because a cone is 1/3 of a cylinder. Okay, a cone is 1/3 of a cylinder. You can, if you look at the pictures beside each other, you can kind of see if I stuck this cone in this cylinder, I've kind of got like 2 other ones here on the side almost. You want to look at it that way, but it's the same formula, it's just got the 1/3. So this time, they tell us the volume, okay? They tell us the volume. It says that the cone is filled with 27 pi cubic centimeters, so that is our volume. 27 pi is our volume. On the other side, we've got the 1/3 pi. They tell us the radius is 3, so 3 squared. We're looking for h. H is the variable we're trying to solve for. So we're trying to solve this equation. First thing we need to do is I would simplify what's over here on the right side. 1/3 times 3 squared. 3 squared is 9. 1/3 times 9 is 3. So we've got 3 pi h when we simplify is equal to 27 pi. How do we solve for h? Add, subtract, multiply, divide. Divide by 3 pi. So the pi's cancel. 27 divided by 3 is 9. 9 what? Centimeters. 9 centimeters is the height of our cone. 9 centimeters is the height of it. Okay, let's look at the back. Gus has a fish tank that holds 4,710 cubic inches of water. He's using a cylinder-shaped bucket with a radius of 5 inches and a height of 20 inches to fill the tank. How many times will Gus need to fill the bucket to completely fill the fish tank if he doesn't spill a drop? So what do y'all think? What do we need to figure out first? Okay, we need to figure out how much the bucket holds. So the bucket is a cylinder, so volume of a cylinder is pi r squared h. The radius is 5. The height is 20. Okay, so 5 squared times 20 is 500. And I think this problem, where I got it from, said to use 3.14 for pi. I usually don't like to do that, but they do this on purpose because it makes the problem work out nice and even. I usually use the button on the calculator for pi, so I'm going to put over here in parentheses, pi is, I'm going to do pi approximately 3.14. Okay, I usually always use the pi button on the calculator, but just make sure you read the directions. Sometimes they'll tell you to use 3.14 instead of the pi button. So that gives us a volume of 1,570 inches, cubic inches. Okay, for the bucket, we need a volume of 4,710, so we just divide, right? To find out how many times we need it. And that gives us 3. He will need to fill up the bucket 3 times if he doesn't spill a drop to completely fill the fish tank. All right, as runners in a marathon go by, volunteers hand them small cone-shaped cups of water. The cups have the dimensions shown. Abigail sloshes 2/3 of the water out of her cup before she gets a chance to drink any. What is the volume of water remaining in her cup? So volume of a cone, 1/3 pi r squared h. Write it down. I know you don't want to write down the general formula. You just want to start plugging in the numbers. Write it down. I promise you it will help you memorize it. You've got to memorize it. So the more you see it, the more you write it down, the more it's going to become ingrained. Let's leave it in pi first. Okay, so multiply everything but the pi. 1/3 times 3 squared times 8. So 24 pi is the volume of the cup. But that's not the question. The question is, what's the volume of water remaining in her cup? Because she sloshed out 2/3 of the water. So what do I need to do with that 24 pi now? Okay, divide by 3 or multiply by 1/3, however you want to look at it. She sloshed 2/3 out, so she's left with 1/3. So she's left with 8 pi, or let's go ahead and get the decimal. 8 pi is approximately 25.133. What is this in terms of centimeters? Cubed, because it's volume. Okay, centimeters cubed because it's volume. Any questions? Okay, y'all can do this one.